Hello everyone, welcome back to this tutorial. In our last tutorial, we discussed how to begin analyzing data. We saw how to visualize nominal and ordinal data using bar charts. If you are new to this channel, I highly recommend you watch that video first. In today's session, we will begin analyzing quantitative data. But before we proceed, let's revisit an important concept that you will hear me mention again and again, regardless of the data type we are analyzing. That concept is distribution. The distribution of data refers to how values are spread out or concentrated within a data set. In simple terms, where do the values appear more frequently and where are they rare? We determine this within the boundary of the data, which is defined by the minimum and maximum values. The difference between these two is called the range. For example, if student ages range from 10 to 16, then the range is 6. Having understood this, now let's proceed. We cannot always use a bar chart directly on numeric data, especially if the range is large or the values are continuous. Continuous data can have an infinite number of possible values. For instance, values like 39.9, 40.1, and 40.2 are all valid weights. Plotting each one individually will create a messy and confusing chart. To handle this, statisticians group numeric data into class intervals. This technique allows us to treat continuous or wide-ranging values as grouped categories. We begin by sorting the data in ascending order and then divide it into equal intervals. Each of these groups is called a class, and the span it covers is a class interval. Let's go through this using this example. Here is our data set of student ages and their exam scores. For now, we'll focus on the age. The age is numeric and discrete data. We will start by constructing a frequency distribution table. I will draw my table and label the headers as you can see. Next, we sort the values in ascending order and then decide how many groups we want. For simplicity, we will go with 5 class intervals. Since we want 5 groups, then let's mark out 5 distinct rows to accommodate each class. The class interval is the technical part, but it is not difficult at all. In fact, it is nothing to worry about in today's world because every data tool out there eliminates this step completely and they do it more efficiently. But we are going through these phases to understand the first principles. Let's go over the steps for creating class intervals so we can group and analyze students' age effectively. Recall that we have decided the number of groups or intervals, which is 5. Next, we calculate the range of our data. The range is the difference between the highest and lowest values. In our case, the minimum value is 18 and the maximum is 50. So the range is 50 minus 18, which gives us 32. To figure out how wide each class should be, we divide the range by the number of intervals. That is 32 divided by 5, which equals 6.4. Since we are working with the whole discrete data, we round this up to the next whole number, which is 7. This is done to accommodate the maximum value in the data. This number is called the class width. It tells us how many values fall into each group. Now, let's create the class intervals. We'll start with the minimum value, 18, as the lower limit of the first class. Then we keep adding the class width to get the lower limit of the next class. So the lower limit becomes 18. 18 plus 7, it becomes 25. To find the lower class limit of the next class, I will add 7 to 25, it becomes 32. And then I add 7 to it again, the next class lower limit becomes 39. And finally, I add 7 to 39 to get the last lower class limit, which is 46. As you can see, the next step is to find the upper class limit. A simple way to do this is to take each lower class limit and add the class width minus 1. For example, the class width is 7 and 7 minus 1 gives us 6. So for the first class, we add 6 to the lower class limit 18, which gives us 24. And that becomes the upper limit for the first class. I'll repeat this for each lower class limit. 25 plus 6, 31. And for the next class, 32 plus 6 equals 38. For the next class, 39 plus 6 equals 45. And lastly, 46 plus 6 equals 52. Now, we have our full class intervals. This method ensures each class has the same width and no gaps between them. Next, count how many edges fall within each class interval. For the first class interval, we have 2 values in this category. And for the next class, 25 to 31, we have a total of 9 values within this range. For the next class, we have 4. And between 39 and 45, we have 4 values as well. And finally, we have 1 values between 46 and 52. All things being equal, the total number of values must match the sum of all frequencies. If not, there's an error in counting. Now that we have built our frequency distribution table, we can move on to visualization. For numeric data, the best option for a univariate chart is a histogram. A histogram gives a clear picture of how data is distributed across intervals. Let's draw our histogram. Start with a vertical and horizontal axis. On the horizontal axis, label your class intervals in ascending order. On the vertical axis, use a scale that covers the frequency range from the minimum frequency up to just above the maximum. Draw bars for each class interval based on their frequencies. Don't forget to add a chart title. Notice that in a histogram, the bars touch each other. This is what separates it from a bar chart. Though we group the values in intervals, the data still retains its numeric nature on the number line. As usual, we will observe and document what the chart tells us. But before we get into that, let's discuss what to look for when interpreting a histogram. Number 1, the peak of the distribution. Look for where the data peaks. A single peak is called unimodal. 2 peaks means bimodal, and more than 2 means multimodal. A peak represents a cluster of frequently occurring values. If there is more than 1 peak, that could suggest subgroups in your data, and it is something worth exploring further. Number 2, skewness. This simply identifies the direction with low concentration of data, and because of its tail-like appearance, we regard it as a tail. Skewness helps us understand the spread and balance of the data. Now, here are the specific cases with skewness. If the tail is longer on the right, the data is right skewed. If the tail is longer on the left, that means the data is left skewed. If there is no noticeable tail and the bars are evenly spread, it is a uniform distribution. And finally, if the distribution is bell-shaped, it is called a normal distribution. Lastly, the range. The range plays a key role in describing how spread out the data is. It helps understand the full scope of the data set and can reveal patterns such as subgroups indicated by distinct peaks or gaps in the distribution. By now, this should give you a strong foundation for interpreting histograms. Now, with what you have learned, let's describe our data set. For our chart, I'll record that the chart shows a unimodal distribution of student ages with a clear peak in the 25 to 31 age range. This suggests that the majority of students are young adults, representing a vibrant and active learning population. The bins on either side of the peak show decreasing frequencies, indicating that fewer students fall into the younger 18 to 24 and the older 39 and above age group. There is also a noticeable drop in frequency as the age increases, with very few students above 45. This pattern shows that most learners are in their early adult years, with fewer people in the younger and older age groups. From raw data, see what insights we have extracted from the data just by visualizing using a histogram. We would typically follow this step to analyze continuous data too. I will skip to show the histogram of the exam scores of the student. As our custom is, visualize and comment. Let's go ahead and do that. My observation would be the distribution of student scores displays a distinct bimodal pattern with noticeable peaks between 55 and 65 and 88 to 99. This suggests the presence of two performance groups, one with moderate scores and another with significantly higher scores. The gap between these two peaks raises questions about what might be influencing the variation. To investigate this further, I am curious to see whether age has any impact on exam performance. Notice in my reporting, I used whole numbers throughout. That was intentional and it is for simplicity. I was simply describing what I saw on the chart without diving into decimal level precision. In real-world data, the shape of the distribution can vary a lot, but as you work with more data sets, you will sharpen your ability to spot patterns and extract meaningful insights. As I mentioned earlier, the steps to visualize numeric data using a histogram are quite straightforward with analytical tools like Excel, Tableau, SPSS, Python, or R. Let's quickly see this in action using a Python notebook. Here is the data set I used earlier, and I have visualized it with a bin size of 5. Just like we discussed in the age example, you can see it is pretty much plug and play. Now let's visualize the exam scores using bin size of 6. Again, very little effort is needed to generate the charts. Before we wrap up, I want to leave you with this key point. As a data analyst, you have full control over the number of bins or intervals when visualizing data in a histogram. Think of it like adjusting the focus on a camera lens. Sometimes you need to zoom in or out to get the clearest picture. The same applies here. Tweak the bin size until you get a view that tells the story clearly. Typically, you will want to avoid using very large bin sizes when creating histograms. Why? Because large bins can oversimplify your data, consequently hiding important patterns, clusters, or variations. The goal of a histogram is to help you see the distribution. So if your bin size are too broad, you might miss out on valuable insights. On the other hand, using too many small bins might make the chart noisy or overwhelming. As with most things in data analysis, it is about finding balance. Start with a reasonable bin size and then adjust based on what gives the clearest view of the data shape. With practice, this will become second nature. Alright, This is where we're stopping for now. See you in the next video.